Here's one of these awkward Doppler effect problems. An observer hears the sound of a car's horn as a frequency of 206 Hz. When the car is at rest, the car's horn has a frequency of 200 Hz. And we've got to determine the speed of the car. Well, the first thing you do is you look up your relationship sheet and you can see you have the following equation. You know that the observed frequency, f0, is going to be equal to the frequency of the source multiplied in by this bracket v, speed of sound, divided by speed of sound plus or minus vs. That's the equation in the relationship sheet. Now, we've got to ascertain first of all which of the denominators plus or minuses we're going to use. Now we know that the observer is hearing a higher frequency, which tells us that the car is approaching the observer. Think about the waves coming off the car as it sounds its horn. All the waves have been caught up with the source of the sound. The car is moving this way, the speed Vs, and behind it the waves will be getting spread out like that. So the observer is going to hear a higher frequency, so therefore we know that the car is approaching the observer. So we can use the minus sign in the bottom of the expression in the denominator here. The rule of thumb is if the car is approaching you, the distance between you and the car is getting smaller, and therefore you use the subtraction minus. The distance has been subtracted. Likewise, if the car is moving away from you, the distance between you and the car would be getting larger, therefore you'd be using the addition one, the plus one. But we now know that the car is moving towards the observer, which gives it a higher frequency. The observer hears a higher frequency, so therefore f0 is going to be equal to the frequency of the sound, and it's going to be the speed of sound divided by speed of sound, and it's going to be minus vs because the car is approaching the observer. So now we've ascertained which equation we're going to be used to calculate any of the frequencies. But we're not asked to calculate frequencies, we're asked to calculate this character here, Vs. So that means we have to extricate that Vs from that very complicated looking bit of algebra. So my suggestion is you put in the numbers first to make it easy for you and do the calculations you go on. We know that the observed frequency from the observer is going to be 206 Hz, so we can mark that down in our little data bit here. We know that the frequency of the source of the car's horn when it's at rest is going to be 200 Hz if you measured it. And we also know that the V is going to be equal to the speed of sound, which we know is 340 meters per second. We'll take that for the speed of sound, and there's the character we're trying to find, the speed of the car, the speed of the source of the sound. So let's put the numbers in and see if this can help us in. So f0 is equal to fs times this bracket here. So f0 is 206, so we can put that down, 206, and that's going to equal 200. That's going to be the frequency of the source. Multiply this bracket by 340, divided by, and it's going to be 340 minus the character we're looking for, the speed of the source. Now it still looks pretty horrendous, so what we do is we take our time and go through our algebra. If we multiply this big bracket here by 200, the undoing of that is to divide both sides by 200. So 206 divided by 200, and that's the first move. Now because we've done that, this bracket here is on its own, so we can say it's going to be 340 divided by, and keep the bracket down the bottom, 340 minus Vs. So that's just got that particular equation. Now we know that 206 divided by 200, that's a 200 there. If we do that on my calculator, it comes out to be about 1.03. So we can now put down 1.03, a single number now, is equal to 340 divided by, and keep the bracket in, 340 minus Vs. So we're still keeping a bracket in at the bottom. Now the next thing we do is we get rid of the 340 times Vs, and we do that by multiplying both sides by 340 minus Vs, but keep the bracket whole. So we have 1.03 bracket 340 minus Vs, and that should equal the other side because that's now been removed now. It's going to give you 340. So now we're beginning to see an inroad to find Vs, and our next move is to multiply out the bracket To multiply the bracket, we do this first, 1.03 times 340, and that's going to give us an answer of 350.2. And then we multiply the 103 by the minus Vs, and we get minus 1.03 Vs, and that should all equal 340. So now we're getting to a stage where we can see we can rearrange things to get Vs on its own. So if I take the minus 1.03 Vs and add that to both sides, and then take this away from both sides, I can do the following: 350.2, take this over the other side, minus 340, and that should equal, take this over the other side, change the sign, 1.03 Vs. Ooh, wow, we're nearly getting there. So if I now do that calculation there, 350.2, take away 340, and if I do that in my calculator, let's see what we get. We get 350.2, take away 340, and I'm left with an answer of 10.2. So 10.2 should equal 1.03 Vs. Happy days. I'm down now to a simple little equation here. And that simple little equation, I then can do the following. I can say 10.02 divided by 1.03 divided by 1.03 both sides equals the speed of the source. So 10.2 divided by 1.03, that's going to give me an answer of about 9.9 repeating. So Vs then, if I look up here, Vs is going to equal to 9.9, and I finally found out what the speed of the source is. The speed of the car approaching a man is nearly 10 meters per second, or 9.9 meters per second, in accordance with the calculations. Now it takes a bit of practice to do that, so you have to work your way through it, and you have to work your way through it in a way that you're doing the calculation, you go along and practice with keeping the bracket here. That's the main point here. Biggest mistake occurs here when you cross multiply with the bracket. People forget this, but you've got to remember 1.03 into the bracket, which means you've got to multiply 1.03 by each member of the bracket until you finally get that long equation. So look at that equation, see how it goes, and just keep practicing. It's a tough one.